say. Bees can tell the colors of flowers not because they were designed to do that, but if they couldn't, they wouldn't survive. And if there are many different universes, that the one we expect to live in would be one in which the laws of nature were such that we could live in it. And here's one law of nature, the energy of empty space, that if it were much bigger, we couldn't live in. By the way, there's some fine-tuning in the sense that that number is very small compared to what we naively expected. But it's not fine-tuning. It could have been 0, and we could have lived just fine. In fact, the universe would be better if the energy of empty space were 0. So these guys who think that these things are fine-tuned for us are wrong. If God really cared about us, he would have made the energy of the universe 0, as I'll show you. Okay, but it certainly, if it varied much from what it was, we wouldn't be here. So that has led people to this idea that maybe this fundamental constant of nature is anthropic. It's related to our existence. Now, particle physicists have jumped on this, because particle physicists are way ahead of cosmologists. Because cosmology is one number we don't understand, the energy of empty space. In particle physics, there's many more numbers we haven't understood for far longer. Okay? Why is gravity the weakest force in nature? Why is the proton 2,000 times heavier than the electron? Why are there 3-generation elementary particles? These are the problems that I became a physicist to try and understand. But particle physicists, a number of them, have jumped on this and said, this is great. Maybe we don't have to understand anything. Maybe not just the energy of empty space, but maybe everything is an accident. Everything is an accident, randomly determined, and if there was any different, we wouldn't be here. Then we don't need a theory of everything, we need a theory of anything. And of course, some people think we have such a theory. It's called string theory. So this is my one cartoon. It's not as profound as the cartoons of Jesus and Mo, but it'll do. So one guy says to another, I just had an awesome idea. Suppose all matter and energy is made of tiny vibrating strings. The second guy goes, okay, what would that imply? The first guy goes, I don't know. So that's the story of string theory over the last 40 years. String theory was created, people thought it was a great idea. It'll tell us a theory of everything. It'll force the universe to be exactly what we see. But in fact, it has this problem. It has 10 dimensions or 11 dimensions in the theory. We only see 3 or 4, and you have to get rid of the others. Normally we think by compactifying them into small scales that you can't see, if the theory were true, and we don't have any evidence that it is. But every different way you compactify those extra dimensions produces a different 4-dimensional universe. A different universe with 3 dimensions of space and 1 of time, where the laws of physics are different. So every wart in string theory becomes a beauty mark, because now they call this the landscape. Because if string theory were true, there'd be 10 to the 500 possible different universes, in every one of which the laws of physics would be different, but in one of which, at least, the laws of physics would be what we see. And the energy of empty space will be what we measure. Now, is this science? I don't know. Because if you have a theory that can predict anything, then anything you could measure would be consistent with the theory, and there's no way to falsify it. This is a problem. But it may be true. I mean, it may be a fundamental problem at the heart of physics. This may be true. It may be that the laws of physics are determined accidentally. But if they are, then the laws of physics come into existence when our universe comes into existence. And if that's the case, in my opinion, that is the last nail on the coffin of those people who need God. Because in that case, you create not just particles in space, not just the space, but the laws themselves. They all arise naturally from nothing. Now, what is this nothing? This nothing is actually, in some sense, many possible universes, some of which don't yet exist, some of which will exist tomorrow. Something we call a multiverse. It could be that there are an infinite number of possible universes that could come into existence in an infinite region, some of which doesn't even exist because you create the space of that region as the universe becomes created. We call that a multiverse, and I want to point out that in some sense, philosophically, that multiverse fulfills the role of what these guys here needed for their God. Because it is the equivalent to what Aristotle might have called the prime mover, or the Catholic Church would call the first cause. Because the multiverse, they need something that lives outside of time. I'll pretend I'm that here. Anyway, they live here outside of time, outside of space that might be eternal. And they say, oh, it's a God. But in fact, a multiverse could be just that. It could be eternal. It lives outside of our space and outside of our time. Now, when I've talked about this, and I've debated this to some Nudnik apologists, like Dinesh D'Souza and others, they say, you know, you created this multiverse because you don't like God. Well, it's true, I don't like God. But that's not the reason it's arisen in physics. It's arisen in physics because we've been driven to it by observing the universe. We don't even like it, some of us. I'd prefer fundamental laws that I could predict from first principles, and maybe that's the case, I don't know. But we've been driven to it by the universe. God didn't enter into the question at all, or the existence of anything. We just wanted to understand how the universe works. Okay, last, happy to say, the last kind of nothing. And I do this, I'm only doing this good deference to my late dear friend Christopher Hitchens, who we all miss. And the world is a lesser place because he's gone. Christopher was writing the foreword for my book before he became too ill to complete it. And we used to talk a lot about science anyway, we used to. And he illuminated many things for me about the world. And when I was telling him about this, he said, you know, nothing is heading towards us as fast as it can be. And what do you mean by this? You know what? I think because I've taken a little too long, I'm going to skip the details. It's a pity, but it's beautiful, but I'm going to skip it. No, I'm not going on too long. No, you can't convince me. I'll say it in words. I'll say some in words. The key word is that the rest of the universe is going to disappear before our very eyes. Because if the universe is dominated by the energy of empty space, then it's expanding faster and faster and faster. And distant galaxies are moving away from us faster and faster and faster. And eventually, they'll be moving away from us faster than the speed of light. That sounds like it shouldn't happen. Because we taught you in school that nothing travels faster than the speed of light, but we lied. You have to be like a lawyer and parse that a little more carefully. Nothing can travel through space faster than the speed of light, but space can do whatever the hell it wants. And space can carry objects away from us faster than light, and that's happening now. And as the universe speeds up, more and more galaxies will be carried away from us faster than light, and that means you won't see them. I was going to talk to you exactly about how they disappear, but it doesn't really matter. What it means is, in the far future, not on our planet, but a planet, let's say 100 billion years from now, or 1 trillion years from now, and there'll still be stars like our sun existing there. There'll be civilizations that evolve on organic materials or on stars. They'll develop scientists, and those scientists will discover the laws of physics. They'll build telescopes. They'll look out, and what will they see? They'll see the universe we thought we lived in 100 years ago. Because all galaxies other than our own will have disappeared. And 85 years ago, that's what science thought. Science thought the entire universe was our Milky Way galaxy, a single human lifetime ago. Put that in perspective. That's why we're just like the early map makers trying to understand the universe. It's not surprising that we're surprised all the time. In a single human lifetime, we've gone from one galaxy to 400 billion galaxies. But in the far future, they'll only be able to see one. And moreover, they'll even get a worse picture because they won't have any idea the Big Bang happened. And I will spend 2 or 3 minutes on this, which I don't normally talk about. Every bit of evidence for the Big Bang will disappear. The Hubble expansion, the fact that universes are moving, or that galaxies are moving away from us, will go away because the galaxies will have gone away. The galaxies are tracers of the expansion. If we can't see other galaxies, we won't know the universe is expanding. The first bit of evidence for the Big Bang. What about the cosmic microwave background? That beautiful afterglow of the Big Bang. It's going to disappear. Because, in fact, here's a picture of it now. A Nobel Prize winning picture, it turns out. It will go away. Because as the universe expands, that radiation will redshift. It'll get longer and longer frequency, and its intensity will go down. So when the universe is 100 billion years old, 10 times older than it is roughly now, then the intensity of that radiation will be down by a factor of 1,000,000 million. That means experimentalists will have to be 1,000,000,000 times smarter. Well, that's easy to expect, but it turns out that won't work because our galaxy has free electrons in it. And because it has free electrons, there's something called a plasma frequency, which you can calculate. And a plasma frequency says the radiation below a certain frequency can't permeate our galaxy. And that frequency happens to be a kilohertz. when the universe is 50 times its present age, all of that radiation will have redshifted below the plasma frequency, and it won't be able to get into our galaxy. So observers who even build a detector, or don't know what the hell they're doing, and look anyway, won't see anything. No Hubble expansion, no cosmic microwave background. The last pillar of the Big Bang happens to be the fact that we can predict the abundance of light elements. This is my famous wallet card that I have in my back pocket when people tell me there wasn't a Big Bang. I show them this and I say, see, there was a Big Bang. But we can predict over 10 orders of magnitude the abundance of light elements, and we get the answer exactly right. It's one of the reasons we know there was a Big Bang, and one of the reasons we know how many protons and neutrons are in the universe. But when the universe is 1 trillion years old, most of the helium in the universe, see now 24% of the universe at the beginning of time, 24% of the universe is helium. Stars have made about 4% of helium. But when the universe is 1 trillion years old, 60% of the universe will be helium. Stars could have made all of the helium that's observed in the universe. You don't need a Big Bang to make the helium, or any of the other light elements. So even the Big Bang abundances won't point towards the Big Bang. And so observers in that future will see a single galaxy living in an eternal, dark, empty space that's not expanding, and they'll come up with the picture, the false picture of the universe that we had 100 years ago. It's poetic in a way. And it means that we're kind of lucky right now, and as I've often said, we're very lucky, because we're living at the only time in the history of the universe when we could know we're living at a very special time. And that's facetious. Because maybe in the far future there'll be other observables we can't see today that we'll be able to see that will give us new insights. Or maybe in the past, if we've been smart enough to evolve 5 billion years earlier, there would have been things. We don't know. But in the future, they'll get it wrong. Okay. So falsifiable science will return people to the wrong picture of the universe, which is kind of interesting, because it means you have to have kind of cosmic humility, which is, those two words don't go together very well for cosmologists. But we maybe should realize that we don't yet understand everything. And just because everything fits together with this cockamamie picture, maybe there are new things that will change that picture in the long run. So, to conclude, why is there something rather than nothing in that case, in that awful future, where everything else disappears? Eventually the stars in our galaxy will burn out, and our galaxy will become cold and dark, and the universe will become cold and dark and empty. And in that universe, the answer to the question, why is there something rather than nothing, is quite simply, just wait, it won't be for long. And to me, that may be the most important answer, because it represents the cosmic conceit of humans. And it comes in biology as well as in physics. People assume that we are the pinnacle of evolution. Those idiots who say, why aren't we evolving? Or P.Z. Myers, the idiots who talk to him, say, why aren't we evolving? It's true that they're not. But still, the point is, we assume we are the pinnacle of evolution. It was all here for us. When in fact, 99.9% of all species that ever lived aren't here. And the same will be true in the future. Similarly, we have this cosmic conceit that the universe was created for us, and it's always going to be the way we see it. It's not going to be that way in the future. We are an instant when the universe is the way it is, and we happen to be here now, but it's not going to be that way in the future. The universe is dynamical, and it wasn't created for us. So, I think I'm going to skip Einstein versus God, too, in spite of how beautiful that discussion is, and end, because I really now have overstayed my welcome. And some of you have to pee. Okay. Science has demonstrated that a universe from nothing is not only plausible, but likely. Those are two words. Plausible and likely. They're scientific words. So that means we don't say it, we know it for certain. We say it's likely, and we say it's plausible, but even the plausibility of that is so amazing that I think we should share that more broadly, which is why I wrote a book about it. What we mean by something and nothing has completely changed. I made that bigger now. I have to make it big, so big that even philosophers can understand. Sorry. Because those classical notions of nothing, out of nothing, nothing comes, imply some classical definition of nothing that may be interesting, but it's not the universe. Nothing in the universe means something very different than it did before, as I've tried to show you. And therefore, that question, why is there something rather than nothing, isn't even an interesting question. It's like the question, why are there 5 planets? It used to be fascinating and interesting to Kepler. And he thought it had something to do with the 5 platonic solids, and there's a profound reason. We now understand there aren't 5 planets, there are 9 planets. And there are 9 planets. Neil deGrasse Tyson be damned, there are 9 planets. The interesting question is, how did planets form? And how did different solar systems happen? And the interesting question about the universe is not why is there something rather than nothing, but what, but how? How did the universe evolve, and how can we find out? And those are the questions that science is addressing. So when I tell you that you are insignificant, and you are, when I tell you that the future is miserable, and it is, you should come away from here feeling great. Because we are here at this weird accident, this cosmic instant. And we should, instead of being depressed about the future and the fact that we are not the most important things in the universe, we should be emboldened by that. And realize that the meaning we make from our lives is the meaning we make from our lives. That we are here in this brief instant, in this brief moment of the sun, and we should enjoy that fact and make the most of it with our brains. Thank you very much.